Hi, everyone. I want to thank you all for being here today, especially our presenter, Winka. It's nice to meet you officially. And of course, our Cal Poly host, Stephen Phillips. Stephen and I have been hosting these events several years now at the Helms Design Center. So it's nice to see us continue this even virtually. It's an amazing series. We love hosting it and being part of it. So for those of you who are on the call who don't know anything about Helms Bakery, it was an actual working bakery built in 1931. So it's a landmark historic building that has, it's a good example of a successful adaptive reuse now. The building is completely intact and beautiful bow truss ceilings, really in perfect condition. And we are now a furniture show, a collection of furniture showrooms, restaurants, specialty shops. And the Design Center has 5 to-the-trade showrooms. One of the showrooms, so I'm happy to announce, Stephen, is tenanted, the final empty showroom. So we have, we're expecting Maharam to come in to round out the 5 showrooms in the Design Center. So it'll be Vitra, Herman Miller, Maharam, Adoda, Splash Lab, Louis Poulsen. So we're pretty excited about that. And when we all move out of this virtual world and we get to come back to Helms, we'll be hosting a lot of art, architecture, and design events as soon as we can after May 15th, when we all get to adapt again. I'm not sure. Anyway, but I want to thank you all for coming and to thank Cal Poly for continuing to host the series. It's really our pleasure to be a part of it. Thanks, Stephen.
Thank you, Angela. And thank you all for coming out tonight. My name is Stephen Phillips. I'm the director of the Cal Poly Los Angeles Metropolitan Program in Architecture and Urban Design. We are an off-campus program for Cal Poly San Luis Obispo. We have been running in Los Angeles for about 10 years now. We typically have our location in downtown Los Angeles, but we are now all virtual like the rest of us. And we're excited again to also have these webinar lectures that we sort of recreated to keep our lecture series going, to keep up morale during these challenging times. Angela, Anthony, and the Helms Bakery District have been extremely supportive, great sponsors all these years. So we're happy to kind of do this as a team event. If you don't know much about Cal Poly LA Metro program, we're about 30 students, and you can see them all as participants in Winka's room here. And they're a super great group of students that also intern in offices in Los Angeles, which actually many are still doing, while we have studio design, history, theory, and practice classes for about 6 months every year. So probably with that also said, I should say we have a lot of great sponsors that support us. Of course, Helms Bakery District, HMC Architects, Morphosis Architects, AC Martin, Co-Architects, Theater DNA, Bulltap, Arc Document Solutions, and our media sponsors, of course, LA, AIA, Arconnect, and KCRW DNA. So with that said, I'm going to thank Winka Dubbeldam for coming out. She was supposed to be part of our huge housing lecture exhibition that we were putting on. It was a part of a symposium that we started last year, supported by AVRP Studios, that we now are moving till next year. I guess I'm not so convinced we're going to start up in May, but in the world, but we'll see what ends up happening. Anyway, so Winka, thank you for continuing the lecture series and being part of this. Let me then also just introduce you really quickly. So Winka Dubbeldam is the founder and partner of the WBE certified New York firm Archi-Tectonoics. Dubbeldam is widely known for her award-winning work, recognized as much for its design excellence as for its use of small building systems, sustainable materials, and innovative structures. Archi-Tectonoics work is found in the USA, Europe, and Asia. Archi-Tectonoics recently won the Asian Games 2022 design competition in Hangzhou, China, 2018, with a 16-acre park with 2 stadiums. And it's under construction, open in 2022, and definitely looking forward to hearing more about that. Winka Dubbeldam is also the chair and Miller Professor of Architecture at the Weitzman School of Design and director of the Advanced Research and Innovation ARI Lab at the University of Pennsylvania, where she has gathered an international network of innovative research and design professionals. She also previously taught at the graduate architecture programs at Columbia, Cornell, and Harvard University, among other prestigious institutions. Currently, Dubbeldam is the external examiner of the Bartlett London and was named one of Design Intelligence 30 Most Admired Educators 2015. Publications include the 3 monographs, Winka Dubbeldam, Architect, out of Rotterdam, 1996, AT Index from Princeton Press, Architectural Press, New York City, 2006, and Archi-Tectonics from DAB Publishers, 2010. A new book called Strange Objects, the title of today's lecture, is planned for 2020 with Actar out of Spain, and her work is also published in numerous international architecture and design periodicals. So with that said, we'll have a lecture from Winka for about an hour, and then we'll turn it over to a Q&A that you can all participate. So just so you know, you can raise your hand and we'll call on you and bring you out to speak, or also you can ask a question. So thank you, and all yours, Winka.
Thank you. Thank you, Stephen. Thank you, Angela, for inviting me. Thank you, everyone, for joining and putting our work behind you. It is really impressive from here. It's very nice of you. I put a shortcut behind me. Look, I love how you get dismembered by these images. So yeah, it's a great pleasure to be here. I thought tonight I would start with maybe a sort of a test of how we are developing our book, and I'll tell you a little bit about that. I've had my practice for quite a while. We started in 1994, and I always like to start with the fact that obviously the work you see here is the work of many people. Our office is very active, and you know, it's not just our office, right? It's all the engineers, the consultants, clients, very important also. And I think it is important to remember that as architects, we're teamwork, especially in this period. I'm quite inspired by reading, which is a good thing in this time. And one of the books that has probably inspired the work I'm showing today and the way I work is a tiny little excerpt from a larger book from Edmund Husserl from 1937, The Origin of Geometry. That is, part of the text is his, and then about 3/4 of the book is actually the introduction by Jacques Derrida, a French philosopher. It's a very funny book. So if you ever write a really good text, you might get someone to write a longer introduction about your text than your text is. And that text I like because he talks very much about, well, first he invents words, which I think as architects really love, right? There's always a word that is going on while we think about architecture, and we tend to think about these words. So he had also words, and things that float in my mind right now are things like meaning form, photonomic shapes that he describes as things that get to be gradually developed, and the fact that their becoming is more important than their actual finished shape, which maybe could or could not be perfect. So the whole idea that he thinks of, the other word is beautiful, is things shapes. I don't know how much theory you guys read, but there's a little bit of Graham Harman going on, some thinking about objects and objects. Jane Bennett thinks more about things rather than objects. So we float around these things also because I think it's very interesting to assess where is architecture and where do we feel architecture should be. Should architecture be really important for the city? Is the city important for architecture? So I'm going to start with an introduction. It's a little on the gloomy side, but it's very short, so don't get discouraged by it. But I think it is good to think about these things, and also to set up maybe a premise of how we want to pose ourselves as architects in the world, which is always quite a decision. So I'm going to share the screen right now with you guys. And theoretically, you should see the same thing you just saw, except for this one is animated. So yeah, you see this now double. So this is kind of a little overview of the work. I think what is interesting for us, as every architect, when we started with small projects and then moved into large projects. 2008 actually learned, or taught us, or we learned and it taught us, that it's really important to have small and large things going, because as an architect you're way more flexible. But there is actually another thing we discovered that was very important for us, is that when you have large projects, it could be 5 years that you have nothing finishing and you're just redlining and redlining and redlining. And what we saw in 2008 is, by finishing very quickly, you see here a store in Shanghai. We did soon after the meditation center that you're all sitting in, and that I'll talk a little bit about, as well as the housing that I was actually going to discuss with Stephen in the other original idea. So we do a lot of work here in New York City. I live actually right here, Brooklyn Bridge, and I take the ferry every morning to Dumbo and then to our office on Water Street. So we're very water-based. The office is on the water and I live on the water, although I'm not there right now. I'm on Long Island water, more water. And what I want to start with is where we are in the world. And as we all know, there is, especially you in LA, have some serious forest fires, mudslides, drought, superstorms. And I think what is really important in this situation is that we need to think about what we actually, in what we call the Anthropocene, what we want to do as architects. And I think looking at Americans that make up 5% of the world's population, however, we use 25% of the world's resources. We burn up nearly 25% of the coal, 26% of the oil, and 27% of the world's natural gas. And we cause 30% of all the pollution. So we're impactful. But that also means that we can change the way we impact the world. Now we are in another challenge that we all experience very drastically. Globalization means that we all have the benefits of goods traveling all over the world, knowledge traveling all over the world, and we ourselves traveling a lot. But obviously this kind of constant movement and transport also has very intense negatives. Between SARS, the earlier COVIDs, and the most recent COVID, we have obviously a serious challenge ahead of us. So what we think about in the office a lot is how we can maybe reduce our footprint, and to start thinking about buildings as maybe not only really good living environments and exciting objects or places to be in, but also objects that have intelligence, that have potentially use less energy, can be prefabricated, clean, produced more clean, and potentially could be energy saving. This other slide was out of whack, so we're back. We're back in New York. Here you see a spot, 497 Greenwich Street is a building we built. If we move down here on Vestry, we build another building, and then across from 497 Greenwich Street, we just finished the latest one, which is 512 Greenwich Street. So for some reason, and I lived in a few of those. So yeah, it's my neighborhood, you could say. I recently moved to Brooklyn a few years ago, but this was where I mostly was. So yeah, you're zooming in, you're right at the Holland Tunnel and the river. It's a very nice neighborhood. And here you're zooming in. So actually then, you know, you get at some point as an architect, and this is maybe, you know, I guess I'm still a young architect because I still get excited when I show up on Google Maps. And when you see your building actually showing up in Google Maps is still kind of a fun thing. So yeah, I'll start talking about where we just left off, of what we just finished half a year ago, what we call a triple solid. It's 512. It's a townhouse. And this is the finished version. But how this actually started to come into being was that it was a tiny little townhouse that the client initially just wanted a small extension on. And as we started to look at the building code and the zoning, it turned out we actually were, we either couldn't extend it at all, or we had to build the full extension because the little townhouse started to approximate a tower, and that's another building type. So when this extension got bigger and bigger, we also realized that probably it's important to add something that unitizes it, so that you don't have sort of a binary approach of two units, but you actually start to think of it as a whole new building. Here you see how that sits in the block. So it's actually almost double the height of the existing buildings next to it now. And what was the idea of that is that the idea of an object on an object, but then wrapping it with something that is what we call it a climate skin. And we call it a climate skin because it actually drastically changes the way the building behaves, but also how we could change the role of the building in the city. As I convinced the zoning inspector that I was keeping part of the old fire escape landings, and hence the building suddenly had balconies in the front. Setbacks are happening behind, as you saw in that diagram before here. There's a lot of setbacks behind, but the trellis itself doesn't have any building code because it's not a building. It's actually sort of what we said, a solar screen or a wind screen, whatever you want to call it. So what happens is the building is actually 15% larger than the build form behind it, and hence it's kind of a new, in a way, building type that has that wraps both exterior and interior spaces in one envelope. As you see here, the trellis can open. So where you see the slats being horizontal, those are fixed, and where the slats are irregular, those can open. So the idea is, here you see it again, the idea is really that you wrap all these areas, the exterior areas also in the building. What is strange, and I have not explained this is actually an 8-story townhouse for one family. So the floor plates are kind of room size in a way. There is a glass elevator here in the back with a slot, a really long slot in the facade where the south light coming through the glass elevator, and then there is an 8-story black stair flying up as well. So we, the way we work is, what the book is about is not so much about the finished products of buildings, but a long time ago when I started working, I realized that if I wanted to invent, or maybe invent actually parts of buildings and start to think of kind of the added intelligence architecture could have, that I had to start thinking like a product designer, or not so much as an artisan in architecture, but maybe an actual industrial designer that develops things through prototyping. And part of what we call strange objects really happen in this phase, where we try things out. So here, for example, when we were trying out the trellis, we realized actually through a mistake that we first made in the drawings, that if we folded the panels up, that all these slats started to interweave like bird wings almost. And we started to really love that because it completely transformed the facade as these panels started to open. So this, very sensitive. This little guy is where we actually on the higher floor starting to test actuators so that this can be done automatically. So this is obviously not going to make the sound like this, but it was really important to think of how you're going to open this when it's high up. And then here you start to see how this slowly transforms. The staircase, the extremely high staircase. And then this is the whole building. So this is a quick photo. We haven't photographed this building officially yet. So this is a quick photo we took to show you guys. But yeah, as you can see, it's extremely high. The top ends in a bulkhead with a meditation room. I'll show you in a second. And the building is very, very ancient on the ground floor. So the lower floors, the four lower floors are from around 1890. And as you can see, these brick walls are very old. We were lucky that the building was actually more or less untouched. And the only thing we had to do is like reveal the beams and start to play around with all the new. So here you see the stairs that are flying up. The other thing, what is nice is if it's one house and not a multi-family, you can actually make everything double height. So what we lost in floor space, because it's a quite small footprint, we actually gained by making a huge amount of double cuts and double height spaces and glass to the staircase. So this is not an emergency staircase. This is really a family running up and down the house. And here, actually on the left, you're standing in the kitchen looking up, and the living room is above you in double height space. And the right is where you're hitting the stair. So the stair goes up 7 stories in the back, shooting back and forth, and then at some point it shoots to the front of the building, to the bulkhead. So this is the atmosphere of the lower floors. It feels like really kind of intimate and cozy, but then you have this strange screen in front of you. This is the second floor going up, and here you start to see that you from the stairs have multiple floors that you see. The kitchen. The contrast of the brick is quite beautiful, and this is a quite funny moment. So the building I'm going to talk about next is the one across the street with the folded glass, but they're literally across the street from each other. And here you see also the enormous double height really gives a really kind of a very airy attitude. This is actually where the stairs turned back to the bulkhead. And then this little guy shows, this is a movie Surface magazine or Surface Media made for us. And here you see again a little glimpse of 497. And here you see how the facade works and how these slats really like kind of crisscross into each other. This is the little meditation corner, and then the tiny roof on the, we call it a roof room, because obviously, you know, when you start to wrap the trellis around, it also gives an enormous amount of privacy. So it's not just for climate. It's also where normally on a roof terrace, it's very hot or too hot often. This also gives a great amount of shading. The other thing is that we have on the roofs itself that are not tiles, there is green roofs. So the client has currently a vegetable garden on their bulkhead, which is kind of handy in this particular phase. And then the trellis itself throws really beautiful shading on the bulkhead. The bulkhead is built from a concrete plank from Norway that is produced actually in the US, but the system comes from Norway. And the trellis is made from Trespa, that is also made here, but it's Dutch, and was completely prefabricated. So this is the building from a hotel next door when the slats are closed, and this is how it looks. So we actually calculated that the building saves 85 kilowatts in energy a week. Actually, funny enough, in the summer more than, so the 85 is in the summer, but in the winter it also saves about 50. Because when in the winter you open these slats, the low sun comes really deep into the spaces and heats it up. Whereas in the summer, if you close the trellis, it actually really reduces the heat gain. And because of natural ventilation, you can really cool the building down very easily. And then we ended up in the Neighbor. The Neighbor is actually one of the first buildings we built. It's an 80,000 square foot building, about 25 apartments. And it was what we originally looked at was that warehouse you see there. And we decided that we were going to build an extension on that until we realized that the site next door was part of it. So instead of a small extension like 512 had, we here ended up wrapping the whole building up and over it. And I very quickly realized I love to play with, I like to decode the zoning in the sense that, you know, if you realize that zoning will ask for restrictions, if you keep reading, it also allows for a lot of things. So you can actually add. So whatever I gained or lost, I gain. And then, you know, it's kind of playing chess. So here you see the curtain wall. The curtain wall idea was really the idea of inflection. So where the code has a straight plane up to about 85 feet, the height of actually 512. After that, you have to do the famous setback. And where most buildings have then a stepped setback, I realized that the code was actually an inclined plane. So very quickly, I took decision that these two planes could, in a mathematical form, intersect each other and hence have one kind of system coming down. By separating then horizontal and vertical mullions, I was able to use that inflection and to start thinking of actual folded glass. Reason being is that the verticals are steel and welded, so they actually freeze the folded forms. The glass was actually folded in Barcelona, and the horizontal mullions are just purely for weathering. Again, this building is completely passive solar energy. The west facade is the only one that is glass. The rest is double cavity concrete. And here you start to see the separation of the mullions and also the glass. So it's actually double glazed glass that was super tricky because if you structurally glaze your facade, you have 1/16 of tolerance. And because the folds are going in and out diagonally, the edges are not straight. So instead of the edges being like this, they were slightly like this, which was super complex. The reason why we could do this is that we actually did one of the first parametric models. So this is a little model we made in 1999, still in Form Z. You guys don't know what that is anymore. And Form Z allowed us to make this 3D model with work points, so points in space, X, Y, Z, no dimensions. So in order to get this facade made, where the glass was folded in Barcelona, the mullions were extruded in China, our New York contractor had a workspace there, and then the whole thing was put together in Brooklyn. Everyone, the only thing they got was this model. So there were no 2D drawings made of the facade. Actually, the only 2D drawings made for the facade were made by the manufacturers. So the big changes, and this is not so interesting for you now, but it will be very interesting when you start the practice, is that this was all not done with a contractor. This was all done with a manufacturer, a factory, like a Tesla person. So it was really cool because the moment you work with factories, the precision is much higher. You are way more in control, and you realize that the only way that this little guy actually fit was because we had that 3D model. So you could say it was like the first little parametric model. Later, we worked with Digital Project and CATIA, but I still like this one because it's actually the beginning where everything starts, right? It's not the software you need, it's the frame of mind that you need. So here you see we only had 5 different angles, but actually the back mullions were all extruded to be following the 5 angles exactly. And then you get these kind of spaces. So the other thing I decided is that really in the old days, you know, a wall was for our protection. Nowadays, a wall is like a raincoat. Protection comes from security systems. So what is really interesting is that it can be the lightest possible version of something. And so here the steel mullions, you see them being welded and folding over. And the only thing that also folds over is the glass. So it's just literally sits on pins and has slight steel cables to keep it straight for the wind forces. And you get this very airy environment. On the lower side, we have also a strange moment where the awning folds out. And there's no rules for awnings, so you can make them as big as you want. It's really funny. There's a hole in the DOB. So yeah, I stuck it way out, and then I also realized you can put a ramp on the sidewalk. So I put a ramp on the sidewalk outside of the building, made a little platform in the private area so you could have a glass of wine outside, which otherwise isn't possible in New York. You know, I'm European. I think these things are important. And so here, actually, this section, every section is different. So there's in this section of the wing, every possible angle is different. And then here you start to see how the building sits. It has natural ventilation again. You get these really nice moments where history is reflected in the facade. And then we get to the next building. The next building was an interesting one. So this was a landmark, and a landmark, as you know, is quite stringent. So the buildings next door are protected. You have to build something similar. But what happened is this was an empty lot. There was no building to restore. And so when I went to preservation, I said, listen, I think I'm going to just take the rhythm of the neighbors and overlap them on the site, make a pixelation, and make a modern building with the qualities and the proportional systems of a traditional building, which was nice because the awning keeps going. You get extremely high floor plates because the other ones are lofts. But you get a much more intriguing facade that actually starts to really conceal how many apartments, how high the floors are, what is happening behind. And it becomes a much more mysterious kind of situation. What I thought is if you have a building, essentially what's really important is to think how you can optimize it. And in order to optimize it, we had the north street facade and the south garden facade. This is the opposite of 497, where 497 was for everyone, rich, poor, small, large, everything was doable there. This is only 7 villas, let's say. So these are stacked villas. Every villa is different, completely customized, and nothing is standard. So what was interesting here is to see how we could fragment the space and really start to work on how to give a building identity and character. We think that the phase of prototyping and the kind of moment of invention in architecture is also really important to understand that a building has character and identity and a certain behavior. So the idea that this building starts to become like itself, you could say, starts from these moments of discovery. And probably the moment of discovery here was also that the person who folded my glass in Barcelona told me about translucent stone that they had just invented. And they said, don't you want to make a building with that? So this building is actually built from translucent stone, glass, and translucent glass. And because it is a landmark, we actually found in old documents which stone was used in Tribeca typically, and that turned out to come from a certain quarry in Portugal. So the next step was to look at the facade and to figure out how it works. We always work with the same curtain wall consultant, really fabulous man from Israel Burger. His name is Bill Logan. And Bill is a sailor. So reason why things are very fine and thin is because he understands how to trim sails and hence how to make facades. So here we are. It was a crazy thing to have to do. You have no idea how difficult it is to go to something like this and to predict how your building is going to look. So if you see these trucks are like, you are about the size of a wheel if you're tall. So this is a gigantic quarry. And these blocks are about 7 by 7 by 7 feet. And the way they explain to you how it's going to look is that they have a little plant spray thing. And they spray on it, and when it's wet, the veins come out. And you see the W that is Winka approved it, according to these guys. But I just literally had to see how this thing looked by them spraying a little plant spray on it. And then the next step is how to develop a facade. So this is again a manufacturer. Usually I find these people before I get to the contractor. Ultimately, I do need a contractor to build the building. But I do this whole research phase usually before we bid the building, so that once I start bidding the building, I actually have this resolved. And here, because the pixelation is quite intense, we wanted the thinnest possible mullions. So we got to this really thin fin that is a German system, Schuko, that is also made here. And here you can see it. So I had never seen fins like this. You know, this is possibly the thinnest mullion. I think it's 1/2 inch. It's reinforced with steel inside. The finish is a titanium anodization. And here is, so we came back from the quarry, right? And they started to make ultra thin slices from this stone and then laminated on glass. So again, if you want to figure out how to make something, a prototype is really important. So here we are in the factory looking at the prototype. We're starting to look at how to get the translucency working. And he starts to point here where it's translucent, where it's not. So we figured we could make it thinner still. And then on the left is how we made it. So we made ultra thin aluminum boxes with either glass or stone inside of it. And then what is fun is once it's installed, you get this really strange effect inside. So not only are you now in a space where you have aluminum and stone and glass, but also the old buildings get fragmented and pixelated the other way around, right? So it's not just the building being pixelated. For the inhabitants of this building, the outside is pixelated, which I thought was quite fun. So you get fragments of old in the pixelation. And then we let the stone also go into the bathroom, and we did all the walls of the bathroom the same marble. So it was quite a nice thing. So in the end, we only had a few materials. The building is made out of reinforced concrete poured inside. The facade is that marble, glass, translucent glass, and anodized aluminum, and the bathrooms are all the same. So there's actually sort of 3 materials for the whole building. What is nice is if you go up, the quite cool marble and glass atmosphere changes drastically once you get the terraces and the plants going. So the building changed a lot. We have in the back, we have 12-foot deep balconies that are really like rooms extending out. That's also why you saw all the double heights in the back. But you get then these kind of nice moments. And then this is, I couldn't get a stone plate to fold like a garage door. So in this case, the garage door actually sinks in the floor. And then this little mesh thing goes up. So when you arrive to the building with your car, essentially this happens. And that's the doorman, my friend. So I'm getting into what I talked about earlier, the thing shapes. On our website, you can find a lot of them. I'm just showing one to get as kind of a sort of a strange introduction to what we looked at further in the China project. But we often start thinking about our work in a very small project. You know, there's the biggest innovation we probably have done in the smallest projects. And this one is the one you're all sitting in, and that is Inkscape. Inkscape was a really, really fun project. We call it the ethereal solid. It's almost a solid that doesn't exist, or is very airy or almost ungraspable. And of course, it has to be very quiet, as you see there. So we started thinking about how can we make the biggest possible objects. We like the idea that architecture is kind of massive and solid. And doesn't reveal itself at all points. You might have noticed I tend to veil things, or I tend to make many layers. So this the same. My client was originally in fashion, wanted to start a startup. So this is a startup company for a new meditation concept that is not based on gurus, but really based on your own intellect and how to stimulate your brain to the point that you can use it for Well, probably you get about 60% going, whereas normally in a normal day, we hover around 10-15% of our capacity. So it is worth meditating. That is the point. What we made is, what we started working on is the no judgment idea of meditation. So this is not yoga, this is pure meditation. So that means that people are not necessarily yogi, and we started thinking of it as a ring that is a bench for people to sit on normal. If you cannot sit like a yogi, you can just sit on the bench. The bench also became the beginning of the rest of the space. We wanted the space to be super simple, understanding that if you want to make the space which is completely quiet and meditative, it's also probably the highest engineered space. So I'll explain that in a minute. We also didn't want it to be obvious from the outside, so I pulled from the same bamboo seating ring, I pulled sheetrock up to the ceiling, so it looks like these are very heavy volumes hanging from the ceiling, lightly touching the ground with the bamboo ring. And then this is the idea, what you're doing inside. So these are sort of yogis. And this is our client insisting that we try this out in my office. And you can see my golden retriever, he's also trying. She is also trying to meditate. My client sitting in the middle. And here what we're testing is really like, how is it comfortable to be in between other people? What is the proximity we can have in this space? We also felt like the space itself had to have a very soft entrance, so sort of more like a portal. So we're really diving into it like a deep solid, and then the door is set behind it. We did a long study of how the actual strength would be of the dome, what density we would have to have of the bamboo frame, and which kind of density felt the best and was the strongest. So here we are looking at different diameters of poles. And then here you see that section I just described. So the reason why this section is important is the decision of pulling that wall straight up on the outside had a huge amount of benefits. One is the dome is covered by a sail, an actual sail maker made the cover. But then the space between this wall and the dome itself is very busy. So what you find in there are like the highest quality of micro speakers, because the sound has to be completely even. So wherever you sit in the space, you have to hear the sound exactly the same. This was important for my client because he didn't want it to sound like a guru or God. He wanted to be omni-universal. So if that was the case, then the sound had to be the same. The other thing we do is we filter the air to the highest possible degree, and we put a tiny bit of aromatherapy in there. That you only notice that once you leave the space and you stand back outside in New York and you're like, it's really smelly outside. But you actually don't notice the clean air. And then the lighting was very important. So what I wanted to do is on the seat, you have the lowest ring of light. You're actually seeing the images behind you. And that is kind of the idea of the horizon. The easiest way to meditate is at the ocean of a desert. And that is because you have a horizon line to focus on. So that is the same in this space. The oculus on the top has light too. So when you come in, both are on. And if you start to meditate, the top one goes off. And then again, prototyping. So we did extensive prototyping because this had to be not only built once, it had to be built many times. So my client actually wanted a manual so that we prefab it. For example, it's built in New York, it stays in New York. It gets built in LA, then it stays in LA. So the idea is that the manual makes it possible for any prefab builder to make it locally, so you don't have to transport it. The benches are hollow, so the air conditioning actually runs through the benches. The air comes between the skin and the wall, again, to have no draft. And then different configurations of attaching the bamboo to the seats. And then this was fun. So we did a one-to-one prototype in LA. You guys have to meet this person. This is my friend from Aria. Aria is the largest independent car design company in the US, cars, boats, planes, whatever. And for example, let's say Audi builds their own cars or designs their own cars, but if they do a prototype for the next 25 years, they would ask someone like this to make the far future prototype. So it's a good person to work with. He can make everything. And so here he robotically CNC milled the whole dome one-to-one. Here it's in their showroom. We started putting speakers on the edges to simulate how it would work. And we actually had meditation sessions with my client in here. You realize that clients are not architects, so it's very hard for them to understand what we are talking about. And the very first thing I realized is that we actually have to go all the way and make them understand, you know, what it is. And that is the best way, is to make the space itself. So this is still one of my favorite phases because the thing looked absolutely phenomenal. I still think I want to make something like this freestanding outside in a garden as a pop-up, which is actually the plan at the moment because of proximity and making things larger. So we're probably building a few of these out in nature, which will be really fun. But anyway, we went pragmatic, right? So we go back to New York and we find an amazing prefab company. And of course, for us, it's really important to have clean fabrication, no waste, fast install, understanding that we have to probably build a few of them. So also to kind of understand, you know, how to repeat this. And this is a little study, how we looked at the lighting, or how we figured the lighting out. Ooh, what is that? Do you guys see this white thing too? Let me see whether that's going to work. Oh, okay, I see it twice for some reason. So here you see the light coming up and down, right? So when you walk in, the lights are on, and now you're meditating and the lights are really low. And this is also the kind of music you would probably hear when you're meditating. And then this is the beginning of the ring. It's built from very simple segments. It's a large oval of 47 feet by about 28, I think, feet. So it's a very large space. It holds about 45 meditators. And then this is, this is still in the factory, right? So here we're starting to look at it. The holes are also because of the air ducts coming through it. And then here you start to see all the little air ducts. What you're missing here now is the bench, right? The bench is still coming against it, but you start to see the frame being installed, the oval on the top. And then this is how it sits. So it's absolutely huge. It's a massive kind of elephant-like thing that sits in the space. Everyone is knocking on it and kind of trying to figure out what it is. They get a lot of clients, I think, because people just want to know what it is. It looks like a boat landed in the wrong space. And then here is in the living room. There's two large living rooms, some retail. And I'll explain in a moment. This is the one you're sitting in. So this is actually my client you're joining. And this is before we have all the mats and the seating elements. And then, of course, we had to also understand, like a startup, you don't know. I asked him, are you going to sell things? And he had no idea. So I said, well, I'll make something that could be a sound baffle, could be an art piece. You could just have a lot of it and not use it. And then if you have t-shirts or candles, you can use it. So these are the prototypes again in the same prefab factory called Teats and Bacon, very nice place in New York. And then here, actually from the beginning, we had quite a bit of retail. You also see the seats we developed with Ligno Rosé, an Italian company that is in New York. And then these little shelves also were the inspiration for seats that are in the windowsill. So here you see in the drawing the seats, and then so the idea of these flaps is that they can go up and down. They can either be all up or all down or random. And typically, I think they leave them random just because they like it. And it gives also good acoustic value to the space. And this is how it looks. It's now very, very full. I was there the other day and the retail really took off. It's packed, you can barely see the flaps. And then I thought, it was extremely touching that Wired magazine said that we were one of the 25 best buildings for 2017 or 2016, which was crazy because it was buildings by Hetzer and Moron and Rem and whatever, and we were not a building. We were just essentially a meditation dome or a whole meditation space. There's 2 domes in one space. But yeah, we were very proud of that. So hence I thought I'd share that with you. And then here you actually also see the seating elements. So anomalies, there's one project before I get to the stadium. This is one we're working on in Rotterdam, my hometown country. We're very interested in anomalies. We're currently in an anomaly. What this whole virus situation is not, hopefully, not a normal situation. So an anomaly is something that is not according to expectation, doesn't follow the normal rules, and starts to have the idea of, again, of individuality and character. So when we got the question to develop a tower for Rotterdam, which was basically a mix of a few floors of commercial and then residential, we started to look at stibnites. And stibnites are self-similar rock formations that follow the same rules, but actually grow differently. And we thought that was super interesting to see how you could start to look at towers that way, following the same rules, but starting to evolve in different ways. So this is Rotterdam. It's a port city, and it sits very close to the water. So this is canals, this is the river, and it sits right here. There's actually, this canal goes around it. And this is the weapon of Rotterdam. I'm not so nationalistic, but I just thought it would be fun to have it. And this is where we started to look at. So we started to look at whether these surfaces of the tower could come up and could start to create sky lobbies that in a way pull the lower retail spaces up as public spaces in higher sky lobbies. Here you see it in Rotterdam. In space, it's 200 meters tall, so for Rotterdam, extremely tall. It's typically more like 75 meters. And then here you see, this is the Black, which is actually where my old architecture school was. And this is where the water comes around, as I just said. Now, really important is that these sky lobbies are basically also green lungs for the tower, and they allow light really deep into these public spaces. But the same happens to the lower retail spaces, that there is kind of skylights almost at hip height, let's say, and it brings the light really deep into the tower. For the skin, we started, Holland is a very moderate climate, so we started to look at silver fritting that is quite dense at the warmer facades, and then allow the facade to have air rotating in it so that the cooler facades would help cool the warmer facades. So the idea is to really look at the performance and the life aspects of the building, while then realizing that what our ulterior motive is to give the building kind of a identity and character, especially because of these strange inserts it has. So this is the fritting study, how the north is clear, almost without fritting, and then as it goes towards the south, you get more and more frit. We use solar tubes on the roof and LED lighting on the roofscapes and the street lighting. And here you have the tower. So these are the sky lobbies. The sky lobbies, there's one that is a local little library, one is a gym. So these are quite public spaces, they're publicly run. And one is a restaurant. And then here you have it in Rotterdam. My mouse doesn't want to do what I want to do. And then it's very cloudy in Holland, so we thought this has a little bit of a problem, I think. It might not run the whole way. It's a bit of a heavy animation. But yeah, so the idea is really that, I don't know whether this is going to show you, maybe not. Okay, I might have just crashed the whole thing. This is one kinky animation. Okay, guys, we have to wait for a second, so I might as well talk about it. So the idea is that the facade, as it is silver, it starts to reflect in different ways, the silver frit. Did I freeze completely?
There you are. Awesome.
First time that I ever crashed. Has to happen once. It's too optimistic. Very optimistic. Okay, that was the animation of the year. I have to unbug that maybe. Good. So here we are. I'm going to show you the light later. Here we are in the lower lobby. So you have that very glassy segment. So the idea is really that these anomalies or these glass crystals, as they come down in the line, they actually extend also in that whole lower area, which has extensive outdoor areas that are covered. In Holland, it's quite rainy. So it's nice to have covered outdoor areas, and the retail areas come up quite high in the tower. We cannot go in Holland very much underground. So what happens is you get retail first, and then you get parking garage, and then you get housing. We have our groundwater is right at the, as you know, we're underwater technically. So you cannot really make deep basements. And then the upper sky lobbies you start to see here. So this is one with a gym below and just a little relaxation area above. And then here you see how the sky lobby sits inside of the tower. And then this is what I was talking about. So at night you get these lines connecting the sky lobbies that basically also kind of communicate the tower to the outside. So the detailing of the glass is actually quite simple curtain wall, but the anomalies, the long lines and the sky lobbies are a different kind of glass, but also very different kind of frame. So the idea is that that is essentially two systems. I like to think that if you do a building in life and you have a limited budget, I like to get to 10-15% abnormal or anomaly, and the rest, the 85%, pretty standard. So going to the non-standard completely is a project we did together with very good landscapers called Melk, also Dutch, Milk in English, but they're called Melk. Thornton Tomasetti engineers, MIC, Mobility and Chain, Italian traffic engineers, and Ryan Soames for MEP. So we went equally into this competition with Thornton Tomasetti and Melk. You know, sometimes it's really interesting to think how you can change the model. So rather than having consultants as an architect, we went in as equal partners. And the site, you can see it here, it's a 1.6 kilometer long site, a mile long. Essentially, it's about 14.7 hectares or 16 acres. There's an excessive river really going through. Initially, they had told us it was a little stream. It was not a little stream. It's this thing here on the left, so it's a quite extensive river. And the area is actually a former wetland. So we were also asked to bring the wetlands back and to really think of it as what they call a sponge city. Now, important to understand is that the games are 2 weeks and then there is life after. And as this is a very large program that I'll explain in a minute, for us it also became really important to think of the life after the games. So we looked at who is really using the park, who's using the buildings, and how can we phase the park in different intensities in different times of the day to make it a lively and attractive area for the city. And of course, the park itself is like a green lung for the city, right? Here so what was quite interesting, this is what the organization wanted. The park is cut in the middle by a river and the road, and they had the stadiums right at the road. But we felt that then both sides of the park felt like the backyards of the stadium. So we decided very early on that we wanted the stadiums to be activators and generators in the park itself, so in the middle. and that we would basically introduce a shopping area. They had asked for an underground shopping area, but as it had to be sustainable, that's not sustainable. So we proposed kind of a valley under the river and the road, connecting the two stadiums, and to make that kind of what we call the Valley Village, a new kind of shopping concept. So it's not underground, it's more looking at individual shops combined with actual more shopping area or shopping mall like shops. So the idea really being that you start to activate this park in different times of the day. At night, the stadiums work, or while it's still the games, it's by day, and then the shopping connects them. And after the games, these stadiums can be concert halls or event spaces that then have shopping by day and little restaurants and bars at night. So it also activates the park to be a safe space. So here you see the two stadiums. This in the front is a table tennis stadium. I didn't know that existed in the Asian Games. Is like the Olympics, right? And in back you have the field hockey stadium, and then the Valley Village that connects both of them. Big wetlands over here. Mostly every hill is a building. We have about 7 buildings in this site. Under here is a large fitness center. Next to the Valley Village, these 2 bumps are parking garages, and we have also a visitor center. So this is the importance of the sponge city. So to really think of bioswales, wetlands, perforated pavement, porosity to make sure that the water actually gets out of the site again. And here you see how we were looking at the idea that if rain comes to the site, you try and delay it, filter it, and then store it, also for future watering of the park, and then also to reuse the water for irrigation, plumbing, heating, cooling, and overflows. We made, so this is actually the wetland, right? So with wetland plantings, some tea houses on the edges to make meditative moments. We always like to meditate here and there a little bit. And then here you are in the tea house looking out over the city and over the stadium. And then this is the idea of the shopping concept and the food court. There's also a very large food court in there. And then, as said, these are supplied essentially by the parking garages. So there's trucks entering from the back. Really important was the large solar screen. So these wings, they shade both the shoppers, but also have solar panels on them. So all the lighting from this thing comes from those solar panels. The round pavilions are the shops with grass on top of them, or green roofs on top of them. And then really important is the park really goes down into this shopping area, so that it really is the park dipping down and not a hard area. One of the interesting things is a Zero Earth strategy that's part of Sponge City. So the idea of sustainability and clean working means also you can't take the soil of the site. So by excavating the Valley Village, we actually made mounds on the parking garages, which gives us a really beautiful topography in the site. So the site is really hilly. It wasn't hilly before, but it just became hilly because of the way we worked and then covered certain program. Really important was that we had skylights in them that could open, so you could still have heating and cooling and ventilation. And light in the daylight in the parking garages. The idea also of these wings is that they're wind catchers, so they also push the air down in the valley and make sure you have enough ventilation in it. And then here you start to see how the hilliness really creates a nice way of tucking the buildings into the landscape rather than them sitting on a flat plane. So here is the table tennis stadium. I'll talk about the reason why you see this intersection going on here. And then this is the field hockey stadium. And here you're looking out over the field hockey stadium, and here you see the solar wing. So now I'm on the road, halfway in the site, looking down with the Valley Village going under towards connecting to the hockey stadium. And you see the housing around it. It's pretty much being built up. So the hockey stadium is a really sweet building. I think it's actually two ovals intersecting. Again, thinking about the future of the building, we didn't want a sport field as a rectangle, so we made it a recessed oval in the park. So on the end, you can just walk in, but actually where the stadium is, it's -5 meters. And then we consider the kind of sculpture of the concrete arena, the way we designed the building itself. The wing is amazing. It's a 125-meter free span on 2 trusses, covered in a very thin fabric. But basically, it's a regulation for the Asian Games to shade the visitors. So here you can see, so actually the sculpture of the seating created the building behind it. And then this little gap is where all the installations sit. And then here you see how the field sits recessed inside of it. And then that's the roof on top of it. So you can see it here in transparency. So it's quite a simple building, right? It's just really made by the seating in a way, and then just covered by a gigantic wing. We were very inspired by the bamboo umbrellas that they have that are made from a super small frame and a very large span. So we thought it'd be really interesting to see whether we could work with that kind of idea. I wanted the structure to be really light. So by pushing my engineers like crazy, they said to scare me, the ring has to be really heavy. So this ring that you see here is in scale, goes from 1.5 meter diameter, which is 5 feet, to here on the top. So here on the top to 1 meter, 3 feet. But as you see in scale, that's actually quite interesting. So I thought it's fine. So it's just cables and that big ring, which is super exciting. I can't wait to see that thing. And then here you see how it's shading the visitors, how the building itself is very, very simple. We made the front from glue lamps, so laminated wood beams. We wanted to see whether we could actually work with wood construction for this building, and it's small enough that we could. So here you start to see the beams. It's all bamboo inside. And then the games and the recessed ring. And then the front, we actually have the site moving up to the entrance, also with the grass field, so people can really sit and basically sit on the building and look out over the surrounding areas, because that is also shaded. So we also let the front of the building be shaded to really try and get this building as sustainable as possible. This is my favorite one. It's this is the stadium. This is really geared towards the idea of theater or concert hall after the fact and stadium now. And basically what we realized is that most stadiums are a very singular shape, right? It's all these big whales you see sitting in cities. And so what they are is what you see. And we thought if we actually want to work on this building as a kind of a hybrid and understand it as a multiple function, we have to add complexity to the system. We looked at the Kong, or Chong, as they say in China. It's a beautiful jade artifact that is found in graves. It's an intersection of a square and a cylinder. It's mysterious. No one really knows what exactly it means. So I was kind of completely fascinated by it. And I like, as you know, I like intersections. So I started looking at the intersection first quite literal. And then we started looking at maybe just more simply considering it an object in an object, and started looking at discs offset in 2 directions, but also rotated. So it's not a symmetrical building. It actually has a rotational quality. And the volumes intersect. So here you start to see it's one of the volumes is brass shingles and one is a glass diagrid. And then again, the roof has an opening in the middle, so indirect lighting is also reducing artificial lighting inside. And here you start to see, so essentially the rotational quality you see here in this is a very large 3D printed model. But you see it here, it's essentially just a bunch of ellipses rotated around each other and intersecting. And this intersection actually gives very strange bulges to the facade. So it's kind of almost like a wobbly, bulging facade. And what for us is the benefit is that these layers and the complexity start to give the possibility of natural ventilation and daylighting. So we have, because of the intersection, daylight goes really deep into the layers, and it also allows us to create a VIP terrace over the wetlands. So by rotating in between these layers, you can actually also access different areas. Fun is that you cannot air conditioning the space of a ping pong stadium because the ball is too small, and you would blow the ball around and you would actually disturb the game. So the only thing that you can air condition is the seats, which I think is fantastic. So all the seats are cooled, so you are like, as a person, you're quite chilly, hopefully, but the space is whatever it is. So hence we spend quite a lot of time for the sustainable people of Toronto and Tomasetti to actually naturally vent the space. And then of course, completely focused on this hybrid, we looked at the shape of an arena, a theater, and then decided to make the seating a hybrid, which the client took some time to convince them. So that basically you build in its future already. Here you can start to see that. And then here you see it's a really beautiful fan shape, and you also see the double layers everywhere. So this is the brass shingles, are actually thick overlaid brass shingles, so the building will slowly change color. And again, same curtain wall engineer. I tend to work with people for 20 years. Like, I have my office now more than 20 years, yeah, so I've worked with most people for 20 years. Because once you find a genius, it's important to stick to the genius. And this man, we had a gigantic die grid in the competition phase, and I was already on the brink of normalizing it. It was like 15 meters by 5 meters, which is gigantic. I hope everyone knows meters. If you don't know meters, 45 feet by about whatever, something, by about 20, I think. And then I thought, maybe I should call him first. So I called him, I explained him what I wanted, and he's like, are you kidding? Yes, perfect, just leave it. And so what we did is I explained to him, I didn't want a smooth building. I wanted to be really textured and really catching the light in interesting ways. So what we did is we took this die grid, basically made triangles that you can see here. So by doing this, I have all my glasses planar, but it comes out like fish scales. So you get this really deep texture and all these silver triangular units that basically parametrically follow the facade and allow the glass to be completely planar. So he works only by hand. So I thought for fun, it would be fun for you guys to see. So he literally develops it like this. And then you get a detail like that and that. And I just sent that straight to the contractor. And I was like, I'm not going to futz with this. I'm just going to give him this. Because these drawings are so clear. And he draws everything one-to-one scale without ever using a measuring device. And it's always perfect. He's an amazing guy. And then here you can see the effect. So it's a huge glass wall that rotates around the building. The inner volume is bamboo, with really deep openings here. And then in the 2 layers, you find a bunch of ramps that look like this with LEDs built in. So it's a very simple building inside, but I think it's a great concert hall. And then this is the outside. So here you can see very much the asymmetry, right? So this thing flies this way. The bulges in the facade, you can see here from the intersection. And then this is the planar glass on the die grid. And then how it looks at night. And then you start construction. So that's all a lot of like happy thinking. And I skipped the fitness center and a lot of other buildings because it gets too long. So yeah, here we are. We have a Chinese team, they're called UAD. They are part of one of the, what we have Ivy League, they're one of the Ivy League Chinese universities. So it's a research group that does research in robotics and a lot of advanced architecture. So I'm very lucky. So yeah, I'm standing here next to the dean. This is my business partner in New York. And then these people I work with, and all these people. So they're really, really helpful. I mean, I don't think we could have ever gotten anywhere without them. And then here I'm literally explaining why I think my 125-meter wing is possible. And they are like, yeah, sure. It's not easy to convince them sometimes. And then one day where like I'm really tired from that meeting you just saw, and I'm sitting in the back of the car, and I'm going by car, and I'm looking at this fence that has fancy, shiny edges. And then I zoom in, and I'm like thinking, this looks like our renders. And I realized, well, actually, they have already built. So this is, we haven't started construction yet, right? There's already a thing around the site that is a mile long and has our renders on it. So there's a lot of advertising there. So here you see them. And then this is, so that was the first visit, and then the last visit. This is now, we are arriving at site. I thought it was fun to show you what cars they drive. As Audis, and there is a Mustang, which I thought was amazing. And then this is the site. So you start to get a grasp of how big it is. And actually, if we need to visit, and this is actually the drone showing a photo. I have my local architects. Every few weeks, they fly over with a drone and they hang over buildings and they show me where we are. But also the contractor has big poles and they control the whole thing with cameras and drones as well. So this is more recently where the stadium is going up. You start to see that seating that I just explained to you, and the river is here. When they started building the valley bridge going under, they basically just dried the river. They stopped the river on two sides, and then they dug under the side, which is really interesting to see that happening. And then here we are. So big discussions. I had just figured out something I didn't like, so I was not happy, let's say. Look at my face. I'm like, that wall is wrong. Yeah, but in general, they're doing actually an amazingly good job. And then you see them building. It's quite amazing. So one thing I asked them, because it's opening 2022, they want the buildings ready by 21 because they need to do all the interior fit out and stuff. And I said to them, how are you going to get the trees to be grown up? You know, it's going to be looking really weird. And they said, oh, no, follow me. And they basically had already excavated trees that they used from the site and they're keeping. And they have plantations or places where they have reserve trees that are waiting to be transported. So it's going to be very interesting to see. And then here you actually see, this is the field hockey stadium. So you see the seats going up and that how deep that field is. So here it's 5 meters and then it goes to 0 on the other end. And then this is at night, how it kind of hopefully will look soon. A lot to do still. So here you have the stadium, the VIP terrace overlooking the wetlands. These are the tea houses you saw earlier. Paths along the river. This is the Valley Village again, the road going over, the river going over. So it's kind of a canal at that point. And then the field hockey stadium in the back here with its large wing. That's it. Thank you.
Thank you.
Any questions?
Yeah, no, Winka, that was a fantastic lecture. I know you were great, but I didn't know you were so amazing. I mean, congratulations. This is a fantastic lifetime trajectory that you traveled on, your talents and skills. You really have a lot of abilities, not just the conceptual and design, but technical savvy. It's really quite impressive. And then, of course, you're also a chair of a program, which is great too. Penn is very lucky to have you. I'm sure they know that.
Thank you.
I would be curious in retrospect, because you've been the chair of Penn for quite a while now. Would you say that's had any impact, positive or I suppose negative, on your career advancement and accomplishments as an architect? Because you're so architecturally competent and capable, you know? Like this is a big firm you're growing soon, hopefully.
Yeah, actually, I don't want a big firm. I always have thought that I want to keep my company around 12, 15 people. And we've never, even with all the buildings we've done, we've never gone bigger than that, because I have a friend who's a psychiatrist, and he said once to me that one person can manage 12. Now, give or take that you have a few other people that help you manage, so you can grow a little bit. But if you get any bigger, you become a business manager, and you'll be feeding people and looking for work every day. So I do still look for work. But I think it's really important to, I studied as long as I could. And I also decided early on that I wanted to really build and design and have fun. I'm not a person to think that I have no megalomania. I like to sit in the dirt on site and to actually figure out how to make things. And I like to work with people who are extremely brilliant. Like, the few people I found I've worked with forever. And really, that's why I said in the beginning, this is really not to my credit at all. It is a really big team I've worked with for many years that we do very crazy things with. And daring clients. I mean, I have to say, like if your clients are not willing to let you do this stuff, you're also screwed. So it's important to think about how you set it up. I think one of the things I maybe this is helpful for you guys as you're leaving school at some point. The one thing I realized when I came out of school, I studied in Columbia, my postgrad, MR2. And I thought, okay, there's two ways to start your company. One is you take all the work you can and you make money as much as you can. Or you figure out another way to make money and you do the work you want. And then hopefully, and I go slower, eventually people will come to you for what you make. So one is like, you do everything you can and you just go as fast as you can. And the other one is you accept slowness and you accept struggle. I mean, it took a long time before we built something bigger. But then I also realized, that in the smaller projects is where you really can do the innovations and inventions. And I just accepted that. So, but yeah, I was always teaching. I taught at Columbia and Harvard and Penn, and never at the same time. You have to set rules. I always set rules for myself. So I was never teaching at more than one school, and I was never teaching in the summer, which was why I actually grew a practice. Because I think if you start to teach more than one place, it gets really difficult and hard on you. So I just restricted myself in that way. But I always thought, I love working with you guys. I love working with students. I like the innovation. I started a robotic lab. I mean, if I didn't have the university, I wouldn't be in the robots right now. And, I think the combination is fantastic. The students get to play with my clients. Often when I get a project, I was working on a bottom-up proposal for Bogota. And then when I was done, I said to the client, why don't you pay for the students to come and that they can do the project too? And then you have more research. And he said, sure. So I said, it has a really good feedback between everything, I think. And yeah, I'm probably just a workaholic.
Students, anybody a question? Here's your chance. We don't. Anybody in the crowd want to ask a question? Feel free.
Who's from China? Is anyone from Hangzhou? No?
No.
It's a great city.
I have a question. So first off, thank you so much. That was a fantastic lecture. And I was really drawn to, it came up a lot, the kind of balance between the code and structure with the design and how they'd have this kind of push and pull and how one influences the other. I just kind of want to know, or if you could elaborate on that more and how you approach that and kind of how how influential and really like maybe not strategies per se, but just kind of your thinking going into it, how you kind of deal with those issues, because you have some fantastic solutions to working around them, and I really want to, I don't know, pick your brain as to how you think about that.
You know, I think you just have to have a great sense of humor about things. So I refuse to suffer. So if it gets really difficult, I tend to torture people back. So if they torture me, I basically get pissed off and I start reading the code and find everything I can do that to make it bigger again after they shrink it. So I'm not, I mean, revenge in a funny way, you know, like I like to think that things are like chess. Very early on, so, you know, I get so many times the question, like, how is it to be a woman in a male profession? And I said to them, it's like chess. If you play chess and you defend yourself, you will always lose. But if you play chess and you strategize, you possibly could win. So I think it's, and that's the same with when you do projects, right? Like if you start seeing the rules as something you have to defend yourself against, you will never win. But if you see the rules as something that you could play with and you can figure out rules around or interpret rules, you know, what I love is, like in Holland, knowledge is absolute. You know, the Dutch are terrible, very black and white. And if they make a rule, you have to stick to the rule. But I really realized very early on in the US, everything is about bartering. You can negotiate everything. And I love bartering. So I barter myself out of everything. I just go, I'll give you this. What about, can I get that then? And these inspectors, I drive them crazy, I think. But I like the idea that you can negotiate. So I'm just negotiating. And I think also it's really nice because, you know, for this, I don't just do this for a game. I like games, but I think it's really important for the city to have buildings that are more like really dealing with like porosity of boundaries and, you know, more interesting situations. What was kind of creepy when I did some documentary on our work, and because they're all in the same block, let's say, or radius, I was standing in 497, the folded glass one, and I looked back at 512, and I realized that if the sun is like around 4 or 5 o'clock, it comes behind the trellis, and that building throws massive shadows all over the street. Like it's stripes, it's completely stripy, the whole street. And it's, you know, it is interesting because you realize buildings, if you do something with them, they have a different effect on the street, on the neighbors. They don't just have an effect on themselves. You really can change the streetscape and you can change the way people experience architecture. And for me, it's really important to not make only a building, but to really make a living environment that is super interesting to live in and also very healthy and you know, works with temperature and smell and whatever. I think your senses are really important. So yeah, I think that's the kind of underlying thought is always kind of like how you make things work and how you give buildings character and identity. And that's often in that phase, you know, so when I'm prototyping, a lot of the more like, you could say found object or the kind of aspects you find when you're making something in a workshop with the craftspeople, it's very often that we find things where either I don't finish it or I leave it rough or I say, oh, stop now, don't do anything anymore, let's just do this. So a lot of the kind of working of the more interesting, more visceral part of the project is done actually in the prototyping phase.
We have a question from Ian Crouch. Ian?
It was a great lecture, very interesting, fascinating work. I was wondering if you could talk a little bit about how you work with manufacturers prior to the bid of the projects. I think it seems like that as a kind of element of your process has enabled you to push technically on things that get stalled out as you go into the bid phase. And I'm wondering, through that process, does the manufacturer take on a level of risk that is usually owned by the GC, and just how that process works?
Yeah, that's a very good question. You got the problem. So I'll explain what the problem is. So what happens is, for example, with 497, that was the first time I realized, that I had to do that. So what happened is I thought I was just going to caulk the glass, right? Glue it. And because the folds are really strong and it's a big building, so all this force of this glass coming down, the caulk could not hold it. So I was kind of, which wasn't a problem. I mean, you could stick a mullion there, right? But I wanted the folds to be transparent. So I went to talk to my friend Jamie Carpenter. You probably know him. He's one of the best glass architects, or best architects, but also does a lot in glass, and he's super smart. So I called him and I explained him the problem, and he said, there's a Boeing factory that wants to go into architecture in LA, try them, or try these people in Spain. And I basically called both and got pricing for both. And I did that because when I was bidding it with the contractor, I realized that just the few folds in that glass, which was really like my famous 10-15%, the rest is just standard, made the whole project kind of expensive. Because they thought, okay, this is difficult, so it must be an art piece, so it must mean they have money. I'm just making it expensive because this woman looks like she's going to be trouble. And so I realized that was not going to really work for my clients. And I started looking at these people that could fold the glass, and it was really not so difficult actually to find someone. So both could do it. They actually had the same exact price for the making and the shipping, because going through the mountains from LA, so the Boeing was in LA, outside of LA, and the Spanish people would ship it, right? But it was kind of the same. Anyway, Christmas goes around, we all go on vacation, and then just in the middle of Christmas, this Boeing company goes, yeah, so by the way, that price was for one layer of glass, not for double glazing. So I called the Spanish people and I said, so that price you gave me, is that for one layer or for 2 layers of glass? And they said for 2. So I said, great, you got the project. So I gave the project to them and convinced my client to rebid it, and then had the price for the glass. That really did make a difference. So that's where I learned that really it's worth doing it in advance. The reason why your question is very smart is like contractors don't really like it, because you take part of their control out of their hands, right? Like they are stuffed with someone you like and you want to work with, and they might not like, and they have no control over it. So it's not seamless. It's creating a little friction. But in general, it works okay. Almost all my projects are like that. And I have to do a lot of calming down here and there. But in general, it goes okay. I mean, they blame each other sometimes, but in general, it goes okay. The manufacturers are okay taking responsibility because they are much more knowledgeable than, in a way, a GC, because many big GCs are more like managers, right? They're not necessarily builders. So it really helps you as an architect to have something made by someone who is amazing in detailing and waterproofing and whatever, rather than having guys on site slam something together. So most of my buildings are prefabricated somewhere else, the difficult parts, because I feel you get more precision, it's cleaner, it's in a way much more beautiful, no? And you get a much higher quality. So, but yeah, no, it's not frictionless. And you had a very good question there. It's not always easy. And usually I have 2 that I give the price. It's just because these Boeing guys messed up. What was very funny is that, so they give the project to the people in Barcelona. And a month later, the Boeing company called and said, we heard you gave it to someone in Barcelona. We will offer you the original price. And I said, that's really interesting, because they also had the original price. And, you just lost it because you changed the price. So they gambled. They thought I was only asking them, I guess. which is not a smart thing to do. And they were just doing some sort of interesting power play that, you know, made them lose. So yeah, interesting.
We have another question from Alina. Alina, you should be able to speak, yes?
Hi, Winka. First of all, thank you for the great lecture. A lot of very
Yeah, you're welcome.
interesting stories. You mentioned about sometimes you just have to dare your client. And could you talk a little bit about the art behind proposing something new and innovative without kind of pushing it too far and then end up losing the project?
Mm-hmm. Yeah, that's a very delicate balance, no? I mean, you have to understand, I think you learn that a little bit, you know, once you get going and you have more experience. It is really important to stay in the budget. I don't exceed budgets by massive amounts. And I think that's kind of the rule, you know, like I think clients are pretty flexible, but if you run way out of time and way out of budget, it gets difficult. So if you want to do, and that's partially why I figure out these more difficult parts beforehand, because if you don't, then you do run out of budget. You know, it's just not possible with a normal contractor to build this kind of stuff usually. So that's why, and the client is typically, actually the clients are not difficult as long they really care about time and budget, right, and quality. So that's okay. And the design question is, that comes back to what I said earlier, is how you build your office. So if you build things that you want to build, eventually people will come to you for what you do, which means you hardly ever have to really fight for the design, if that makes sense. Because they already chose you because of what you do. So I don't really have that problem very much.
Thank you.
Welcome.
Is there more question out there? Yes, no, maybe?
You guys all look really good in these buildings.
It's a great building, really incredible roof structure. It's nice to see it changing and evolving and getting bigger and bigger. Congratulations
Yeah, right?
on all of that.
Yeah.
Thank you, Winka. I really appreciate your time. Everyone's so happy to see this work and hear you speak about it. So very cool.
Thank you all for having me, and thank you, Stephen, for having me. And I'm so sorry I couldn't be there in person.
Next time, we'll do it again. We'll do something
I'll
else.
have to try that next time, yeah.
Yeah. Okay, great.
Please
Hey,
do.
thank you everyone for attending as well, and have a great night. Winka, have a great night. Ciao.
Bye, everyone.
Everybody. We'll be back next week, Thursday, 4 p.m. for Michael Meredith and Hillary Sample of Moss. Bye.